Hello, everyone. We are at 11:59 and getting ready to get started. Right at noon Central. So we are going to give it another minute just to allow people to join in. You are attending the NCFI Polyurethanes Geotechnical Division webinar on adaptable solutions using polyurethane. Again, just give us a moment and we'll get started. Just want to give people a minute to join. Uh, just be one more moment. We're just giving it a minute for people to join. And we'll get started promptly here at 11:01 my time, 12:01 Central. Well, it seems the trickling is about to stop, so we're going to get started. Hello, everyone. Welcome to the NCFI Polyurethanes Geotechnical Division webinar. And today's subject is going to be on adaptable solutions using polyurethane. It's really meant to cover non-traditional solutions. There's one of the wonderful things about polyurethanes is it can be adapted into a lot of instances that really are thought of generally. And so we figured today would be a great opportunity to present those and give you some ideas of applications that can be used out in the field. So next slide, please, Tom. Just to introduce myself, my name is Robert Armstead. I help lead the marketing for the Geotechnical Division. I'll be your host today. I'll be monitoring any questions or anything on that line. So if you have questions or having difficulty, please let me know. I'll try and be as prompt as I can, but I'll also be operating the Q&A at the end. A little housekeeping. This webinar is approximately around 1 hour. We usually try to get started finish about 50 minutes in to allow for some Q&A time. But sometimes it does extend afterward. If you've gone beyond the hour and you need to leave, we understand. Our chat is available upon request to coordinate with me or the meeting hosts, such as Mr. Gibbs here. We will be recording, a webinar recording will be sent after the webinar. And then again, Q&A session will be at the end. If you do have a question, I would ask if as you have questions throughout the webinar, feel free, please go on and ask them. It helps us because if we have a slew of questions at the end, a little backlog, it's much easier to not have any delays regarding once questions do come in. But the way that you would ask a question is you'll see in the webinar window, there's a Q&A box. Quickly click that to ask your question. Click ask question. Enter in I want to ask a question in there and then send it along. And then we'll be monitoring that through the webinar. Next slide. And introduce our presenter today. Tom Gibbs is the National Sales Manager for the Geotechnical Division at NCFI. He's been working with polyurethanes since 2007. He's been working in the foundation repair industry since 2002. He has worked on very complex projects and industrial, commercial, residential applications, even working within 2.5 years with Keller North America. He has OSHA certifications and he's completed quite a bit of criterion courses that are very related to this space. So I want to welcome Tom, and Tom, feel free to take it from here.
Thanks for that wonderful intro there, Rob. Appreciate it. So today, as Robert mentioned, we're going to be talking about some of the more unique ways to use polyurethane grouts or polyurethane foam grouts. There'll be a big focus on some of our lightweight fill systems for cavity fill, structural forming, void filling. We'll talk about our trench breaker system, and they're also going to talk about some water structures, waterproofing type applications as well. I do want to just briefly touch on something for those of you that are on today that are contractors using our products, but even those looking at our technical data sheets, engineers looking at our technical data sheets, things like that. We have gone through a recent renaming system. Our old naming system for our systems didn't really mean a whole lot to anybody, barely even to us. But this system kind of helps make some sense out of them. So the NCFI part, obviously North Carolina Foam Industries, the number portion will be your density for that particular system. And then after that, it's followed by a series of various system qualities. So the first will be the speed, slow, regular, or we consider it to be fast, whether or not it's hydrophobic and whether or not it's a low exotherm system. So we're going to be addressing you're going to see a couple of videos on some of these systems, but we're going to start with the lightweight fill stuff. So these lightweight fill systems are great. They're all going to be in that 2.2 pound per cubic foot, zone. Some may come in a little bit lighter at 2 pounds. If it packs in some, you might get it up to about 2.5 pounds, but extremely lightweight compared to your alternatives out there. Great for filling large voids. The majority of the systems that we're going to talk about today are also what we consider to be low exotherm. And that is a huge quality for polyurethanes, because polyurethanes do have an exothermic reaction when they're turning into foam. And a traditional, say, lifting foam, if it was placed too quickly, too thick of a lift, could potentially, overheat, scorch, and or even potentially catch on fire when placed improperly too fast. So these low exotherm systems give us that capability to do thicker lifts. Doesn't mean it's unlimited, but it's a lot better. We have a couple of different systems here. This one is our 24070, formerly now known as 2.2 SX. It's a slow, low exotherm system. As you can see, the total rise time or expansion time of this material is over 5 minutes. It's almost over 5.5 minutes. So if you're trying to flow it through, for say a pipe abandonment or a larger void, you're going to get really good spread out of it. You can see it here traveling in the, kind of cream to gel state. When it's in that state, it's still flowing, still can push through itself. And then it will start to rise, which you'll see here shortly. This, I believe, is actually shot probably in time lapse. So this is actually a little faster, but it would be, being that it has a 5.5 minute rise time, really boring video to watch and very long video to watch if we didn't do it in time lapse. So this gives you an idea of what it looks like it's at that speed, but it actually is much slower than that. The nice thing about this compared to, say, a geofoam block or something like that is zero excavation, and also it conforms nicely to the space, and fills in all the nooks and crannies. Next one is our 2.2 SHX. This is also a low exotherm system. The previous system is not hydrophobic, so it would need to be used for situations where there's not a tremendous amount of water present. That's why we came out with this next system, the 2.2 SHX, is a low exotherm system. A little bit faster rise time at 106 seconds, so a little over a minute and a half rise time. So, great, still excellent flow, not quite as long, but it's also hydrophobic. So if there was water present in the void, then that's going to be a much better situation. You can kind of see this one was a wet situation, not necessarily completely saturated where it's full of water, but it would work in a situation where if you had an abandoned pipe or a void like this where there was water present, you could still use this material. Again, I believe this one is also shot in time lapse, so a little faster than what you're actually going to get, but works really well to fill in those voids. Does not have a lot of lifting capacity. I mean, you put enough of it in there and it could potentially move a slab, so you still need to monitor for movement, but it's not designed to be a lifting foam. It's still in that state where it can kind of push through itself to get all the voids filled in. Now, obviously, we don't always have the benefit of being able to see the entire void like this, where it's wide open. But the use of you know, drilling additional holes, and say if we were shooting this under a slab or something like that, you can drill some additional holes and use a camera to monitor, make sure you're getting consistent and good fill. And our last one in the low exotherm lineup is actually more like a spray foam. We call it, started off as a trench breaker foam, but we found plenty of other uses for it. It's our 2.2 FX. So this one's going to come in around 2 pounds per cubic foot with a much faster rise time, much more like spray foam. Initially designed for the trench breaker industry, and we'll go through that later so that you can see some pictures of what I'm talking about when I say trench breaker. Some people may not be familiar with that, but we'll have some slides on that further down. So these are great, low density, fast, low exotherm, lightweight fill materials that can be used in a variety of applications, and we're going to start showing you a few of those here shortly. So this is the trench breaker foam. This particular one is a really unique one. I personally, I'd be a little scared to be under there, but this is actually underneath a pool that's on a parking deck, from what I understand. I was not on this project, but basically, as you can see, the structure that's holding this thing up was failing drastically, and rather than tearing the entire thing up, they filled in underneath it to give it the support that it needed. The engineers looked at it, determined it was going to be strong enough to hold everything up, and so they went in and filled the whole thing up. So cavity fill solutions, we're identifying when we're talking through this thing, cavities would be your open face, you can see what you're doing kind of thing, and voids would be your under slab, can't see the whole picture kind of things. This one was a utility trench. I believe the sidewalk was poured over this eventually, but basically a conduit bank. You can't really see all the conduit there, but you can see some of it coming out here at this end. It's nice when you're spraying around conduit like that. It's going to get in there and fill everything in. If they ever needed to get to it again, this would be much easier to dig through than concrete. So this was a particularly unique project. I was on site for this one. I believe I even took these pictures. So this is a overflow facility in Louisville, Kentucky, for their stormwater and sewer water. Their systems are combined. It's a little bit weird. But this large pit was being dug. After they got done drilling the rock, they put in some soldier pile walls with lagging and built it the rest of the way up. But in that rock section, the top 4 feet of rock was just so soft that it kept chunking off, and they needed a flat surface to be able to put their forms in later on. And so they couldn't put a form up and pour concrete, because every time they tried to put a form in, lock it into the rock, more rock continued to fall off. And so we came up with this solution. We actually ended up using Pure Foam, which is a spray foam company on this one. They, their guys are used to more of the spray foam type materials. They did an excellent job of building it up, and it wasn't perfectly squared off, but they filled in the voids the way they needed it. So I believe it was probably about 9,000 pounds of material, and took a couple of days to do the whole thing. But the pit is relatively large, 40 foot deep, 300 by 150 yards. So pretty big project. As you can see, anywhere they had fallouts from the rock there, they just built it up, and you can see how the UV had an effect. This was probably day 2, and the stuff that was in there the previous day is starting to yellow a little bit. So polyurethane is not intended to be left exposed for long periods of time, but it will start to yellow a little bit, but the degradation is minimal at that point. It's basically just going to start to get a little flaky on the outside, but less than probably 1,000th of a millimeter of material loss over, say a week period of time left being exposed. It's not going to go away that quickly. Big Sur crib wall. This was a project that Eagle lifted out in California. They were losing soil through this wall, um, through the bridge abutment. Kind of a different design there, but they were losing soil there and filled in and filled all those gaps in and stopped it without having to do any, without disrupting traffic, without tearing anything up and doing major construction. Not as familiar with this one, but it was an effective and efficient way to solve a problem, and still a permanent solution, or at least one that's going to add years of life to the structure. This was a washout from it, and basically a rock slide situation. There was a utility access road above this area, and the slope washed out. They needed to rebuild it to get the road back open. So they came in. Geofoam was used on this project after they built this base up, but this base had to be built first to give them a flat surface to place the geofoam on. And so they came up, sprayed it in place, built it they locked rebar into the rock first and sprayed around all that and filled this in to be able to put to start the EPS wall, in which they then coated with concrete. This was a really unique project I did down in Savannah, Georgia. This was initially basically just an ask from the general contractor. The seek and pile wall was put in Savannah, Georgia to be the walls for a parking garage for a high-rise condo building that was going in. And they wanted to put a dimple board waterproofing membrane in front of it, but they wanted a flat surface to do it. Instead of undulating in and out of the bellies of the wall, they just wanted a flat surface. And so we filled the belly up, and then actually one of the walls was out of place a little bit. So they asked us if we could build it out a little further to match out the design plans, because somehow or another the plans were, or whoever did the layout missed it by about a foot. So you can see those bars sticking out on the far right. We ended up spraying that wall all the way out to the front of those bars. There's a string line on there you can't really see, but super lightweight fill opportunity there. It's also going to stop the water coming through that wall. The dimple board was probably overkill, but it was already part of the design, so we just left it in there. So this kind of just shows all of the various lightweight fill systems, the 2.2 SHX, SX, and F, with the various times, speeds, or rise times. And they're pretty similar in compressive strength. It is a little different, the fact that they're all 2.2 pound foams. There is a little bit of differentiation in the compressive strengths of each of them, but they're going to be in that 31 to 44 psi compressive strength range. All right, we're going to talk a little bit about water control projects now. So most of these projects are using our NCFI 120, which is our single component. Single component systems are all of the dual component systems that we just talked about are 1-to-1 ratio, processed using proportioners and the materials heated and kept on ratio, all that good stuff, and processed through the proper equipment. Single component is a little bit different, and it's typically going to either be run through, say, a paint pump, or sometimes even out of cartridges. Single component does sometimes have a catalyst package that can be added. Everybody says, well, then is it really single component? It is. The catalyst package is basically your ability to adjust that product in the field. It's adding catalyst to it to speed up the process. It's not what makes it react. It's just speeding up the system. So it's just the ability to adjust that system in the field by adding some catalyst to it. When this stuff is put into and permeated into sandy soils or whatnot, it's going to be more of a permeation grout type thing, so it can stabilize those soils. It can be used for water stop grouting. A lot of seawall and bulkhead repair being done with this. Sealing around manholes that are being relined to stop infiltration, I&I problems, tunnels and subgrade utility issues, elevator shafts, a lot of different applications for stopping water with this stuff. This this is a cotton gin out in La Mesa, Texas. The basement portion of it had an old CMU wall that was water was getting through. We went through and grouted that basically with a curtain grouting approach. So curtain grouting, you're basically injecting to the other side of the wall to lock that, to seal that off. Depending on what type of soils are on the opposite side of the wall, if it is a more of a cohesive soil, basically it's going to get between the soil and the wall and create a layer that will seal off the water. If it is a sandy soil, then it is going to permeate that and create a grout curtain on the outside of that structure to keep keep the water out. This particular one took over 400 gallons of material and stopped all the water from getting in. CMU walls can be a little trickier. If they're not filled with concrete, you want to try and get to the dirt side. If they are filled, then you're good. If they're not, then you can end up wasting a lot of grout filling up the CMU. We've actually done some projects where we took one of our dual components that's designed to fill up CMU walls and use that to fill that void first before doing the curtain grouting. It works really well. This was a very unique project, the Illinois Water Cutoff. They were going to build a park here, but in this little bend in the river there, water was going underneath the structure there, the stone structure there. There was basically layers of stone that water was getting in between, flowing through, not over the top, but kind of on a horizontal surface. And so they didn't, because it was all rock, they didn't want to do sheet piles. And so we basically grouted that fractured limestone, sealing off all the cracks in the bulkhead. So basically you can kind of see where the water was coming through, kind of about, I don't know, 12 or 14 inches down. Drilled through there and injected it and got all the water stopped so they could build their structure. This was a sinking pile shaft in Dallas, Texas. Sinking piles, if you're unfamiliar with them, basically are a series of concrete shafts that are integrated together, and they often end up, because of the way that they're put in the ground, you often end up with some small gaps here and there. And if you've got a bad water problem around that area, then any purged water, or just if you're in the groundwater, then you could potentially have some leakage problems in those gaps. This was a relatively small one, but it was producing a pretty decent amount of water, pretty decent flow. And so they had attempted to just inject grout, but the flow was a little too high. So then they ended up using oakum and some shims, and then drilled in at a 45-degree angle from the side. You can kind of see in this last picture where it's where they come in at an angle and intersected the crack about halfway back and sealed it all off. So got the whole thing sealed up and solved the problem. This was really a relatively small job, but the alternatives for fixing it were few. They needed to stop that water so that they could dry the pit out, and this was an excellent way to do it. So void filling, when we talk voids, this one's kind of a combination of a cavity or a void, but there is a void up underneath this slab, but it wasn't done with an injection approach because it was exposed. They were able to use the trench breaker foam to spray up underneath it reestablish contact with the slab to the earth, and then filled in this portion, just with soil afterwards. This is back to that rooftop job, and somehow or another we ended up back on that one. But so we've already covered this one. We'll just skip over this one. Well, there are some videos for it. There's quite a bit of it on here. It seems like we got a little bit out of order here, but as you can see, there was quite a bit. It was a fairly large project. They did do, looks like, some structural repairs in some areas, but a lot of it was just left as is and filled up with foam. Another very unique project. This one was just completed last year. The Crown Plaza in Louisville, Kentucky had a pool, an indoor pool. It looks like an outdoor pool. It is covered with a glass ceiling, and it's smack dab in the middle of the hotel. And they did not want to bring in heavy equipment. They didn't want to take out the roof to bring in heavy equipment and demo everything. But basically, they needed to make the pool smaller. Kentucky passed the law that said if it had X number of square feet, you had to have lifeguards, and not a lot of hotels have pools with lifeguards nowadays. So they wanted a smaller pool. So they decided to fill in around it. So they built this steel structure. All this debris is from tearing up the coping around the outside of the old pool. We use the 2.2 SH. Actually, I think we use SHX to get down into the rubble. And so it was shot down in there, allowed to permeate down into the crevices and nooks and crannies. And then to speed up the process, after we had all that rock locked together, or all that debris locked together, they used the 2.2 FX, which is the trench breaker foam, to fill in the rest of the pool. And there's your finished project. There's your before and your after. So now they've got a pool that is more manageable and doesn't require lifeguards, and back open to the public. This is an older project, but still a very cool thing to use this for. Basically, in this particular case, this particular contractor may have taken a different approach with this if it weren't for the access. This is very difficult to get to, and bringing a batch truck in to do cellular concrete or anything like that just wasn't an option. It's a long tunnel, and 849 feet, been closed for a while due to erosion. They put a new liner in it. They needed to fill that annular space around that liner. So 120,000 pounds of our now 2.2 SX, which at the time was labeled 24070, was injected between the liner and the bridge, the original tunnel. Yeah, these are easy to, when you're doing them this type of job, it's easy to monitor to make sure you're getting complete fill, because you can use thermal imaging to make sure that you're getting to all the areas when you're working with a steel liner like that. It doesn't always work when it's a concrete liner or when you're dealing with concrete, but it works really well when you're dealing with metal. Another really unique project done last year. This is in Alexandria, Virginia, and this building, unfortunately, I don't have any great pictures of the outside of this thing, but it's a new construction building, and it was designed this way. This is to be a restaurant, and so that's all the floor drains and plumbing and all that stuff that you see popping up. But this is directly over a parking garage for this condo building. The restaurant's going to be on the main level, street level. You can see that door in the far right picture. That door, the threshold for that door is 3 feet above what the original grade of the concrete was. So they wouldn't allow them to put the plumbing through the floor down into the parking garage because they didn't want the penetration there, and they didn't want to lose the clearance down there. So everything had to be built on top of the slab, but the slab could also not support filling this in with gravel, concrete, or even cellular concrete. It needed to be something super lightweight. So the other challenge here, and the reason we used our 24028, that's our cavity fill product for CMU walls. But because it is an insulation product for CMU walls, it is also E85. It's higher. Most of our geotechnical foams are not uh, tested that way and rated that way, and they don't have the fire retardants in them because it's not needed necessarily. But there was a requirement for this project, regardless of the fact it was going to be encapsulated completely by concrete. They still wanted that. That's what we had to give them. So very unique project. CJGO did this one. I don't remember the total square footage of this room, but it was a pretty big, probably somewhere around 2,000, maybe 3,000 square feet. And basically 2 foot 8 inches, because I left 4 inches for the slab poured on top. Another really unique application. So when you're building a shotcrete, shoring wall, sometimes you run into problems with when you're digging the lifts. In this particular case, as they were digging the lifts, they would come back the next day and there would be huge fallouts. The clay would dry up overnight and just large chunks, 3 to 4 feet deep, were falling out. They needed a way to fill those cavities up. Shotcrete could have been used, but it would have taken a really long time because you have to layer it in or form it up or something. Would have to be done a little bit differently. And with the foam, it's lightweight. The desire wasn't necessarily for this to be structural. It's not locked in, but because it is the spray system, it'll attach itself to the dirt pretty well. Then they'll put more wire mesh up, and as you see on the far right, they sprayed right over it. We had no adhesion problems with the shotcrete. Worked really well. There are, there's none shown here, but there are drains that go behind this wall. We had to work around those. You got to still have proper drainage behind the wall, but this was a really good solution for a problem that was occurring on 2 different job sites here in Knoxville, where I live. This was a very interesting one. This is a little more traditional, but this was day one where I came down to look at this project, and this was a Purdue chicken plant down in Georgia, and they were flushing out some drains. They thought that they had a clogged floor drain, and they jetted it and found out that it was not indeed clogged, but rather broken, and it created a huge washout. So this production line at this chicken plant, it's not your traditional like where they kill the birds kind of thing. This is where they make chicken nuggets. And so this production line is about probably 60 feet wide by 200 yards long. And various rooms had different types of equipment in it. In one room we had a big oven. In one room we had this big freezer. This freezer is on your right here. That thing's built in place, and there's no way working around it. Where they didn't have equipment, they wanted to just go ahead and replace all these floor drains and all the plumbing. Of that 60 feet, the original trench that was dug for these utilities was probably only about 35 or 40 feet of it in width. They did a horrible job of recompacting that and installing the plumbing. That's where the failure was. So when they went back to build it back, they said, well, we're going to take out where we can and recompact, do it right, replace all the plumbing. They ended up putting in stainless steel plumbing instead of PVC because they didn't want it to happen again and whatnot. But in areas where they could not move equipment, as I said, this freezer was built in place. It's 2 stories tall and 50 feet wide, and 50 feet long. It wasn't going anywhere. So, but it did have a void. Luckily, it was wide enough that it was still sitting on good soil on either side, but there was a void, a belly-shaped void throughout the center. And so we went in and we pushed PEX tubing to the center. We had access from both ends of the freezer, and we just basically pumped foam till it came out on the other on this end, and filled all those voids up to reestablish contact with the soil. Is all we were trying to do there. And then anywhere they didn't take out the slab, we did void fills just to make sure that everything was filled in. So we just basically void fill until we got a bump on our level. We also went through and all these PVC pipes that they didn't have access to tear out, we abandoned those with the 2.2 SX, filling those in just to keep them from being an issue down the road. This project was over in Montreat, North Carolina. This Gavion cage wall supports that road that you see up in that top picture up at the top there. 100-year flood came through. Water level was up above where you see the sandbags in that top picture. And this was before Helene. I actually have plans to try and make it back down there and take some after pictures to show that, from my understanding, this survived Helene. And so that went right through. This is Montreat. It's very close to Asheville. The bottom layer of the base for that wall is basically geofabric with riprap wrapped up in it. But there was about an 18-inch gap below that. So in order to form it up and keep it contain the material, again, this was about 18 inches tall and went back 3 feet under the wall. One section was like 27 feet and the other was 30 total. And so we went in and put the sandbags in, used PEX tubing, pushed it to the back, started at the down creek side so that any water that was still getting back there would just push the foam towards the end instead of it potentially messing up the flow, and filled up all of it. Bottom right is your final picture. They told us just to leave it that way. They were going to bring in some large river stones similar to this boulder and place them in front of it to kind of hide it. It is, heavily hiked and a lot of sightseeing type people there in Montreat. So they wanted it to look pretty. And we realized that's not super pretty, but but they did cover that up. We also had a boom downstream to catch anything that did escape past the sandbags and get out. By the time it gets past the sandbags, it's solid foam. We use the 4RH, which is a 4-pound density, compressive strength, pre-rise about 80 psi. So you can see there was already a bow in the wall, and that's not because we threw all those sandbags there and it was already there. But we didn't try to lift. We just wanted to get that filled in, all that scour filled in. Completed the work in 2 days. Trench breakers. We mentioned this at the beginning of the presentation. Trench breakers are used in the oil and gas industry for the installation of pipelines. Ironically, the sandbags that we just talked about used to be used for this type of application, but with OSHA regulations trying to keep humans out of the trenches as much as possible, it's a very labor intensive. Yes, sandbags are going to be a cheaper product, but there's a lot more manpower involved and a lot more risk of injury. 50-pound sandbags being tossed down into a trench. Not all the trenches are this shallow. A lot of them are a lot bigger, so it can be kind of dangerous. Can be used for brakes and or riser supports or pillows, another term we've used, and also for risers like this. It can help with stop vibration when you've got this axial displacement here, and then pillows are just used. Basically they put cribbing in underneath the pipes when they're putting the pipe in the ground. They'll spray pillows right next to it, then remove the cribbing so that it doesn't rot over time. This is one of the taller ones. The nice thing about this can be sprayed down into the trench from the top. Nobody has to be down inside of the trench to do this work. And that's all we've got on that. So we've got plenty of time for some Q&A.
All right. Thank you, Tom. We've got 4 great questions right now and plenty more hopefully coming along. So thanks to those who are asking questions along the way. First question, how's the durability of these products?
So polyurethane foam, we had a third-party study done on it a long time ago, but we also test for dimensional stability. we had a test done a long time ago on it to determine, what's the lifespan of polyurethane, how long does it last in the ground or in general. And granted, this was done with the Department of Energy. It is, a test to determine the accelerated lifespan test is what they call it essentially, and that shows that the stuff's going to be around for 1,000 years. I mean, it's not going anywhere. The dimensional stability of the product is exceptional. UV is about the only thing that degrades it and tears it up, and that's a long process for that to even happen. So, very, very durable stuff in the ground. Even with moisture present, it's going to last a good long time.
Yeah. I will kind of add a couple on that if you don't mind, Tom.
Sure.
There are a variety of solvents that we have to be aware of. So if you do have a situation where you have some contaminated land, so those solvents aren't really a great opportunity for the polyurethane to effectively react, or could effectively, could hurt the polyurethane over time. But again, UV and some really interesting solvents out there are some concerns. But outside of that, there's some. It lasts for a good long while. And I know of some of our customers have done their own testing through use in DOT applications through repetitive use, and the over 10,000 cycles and no degradation within a lot, which is better than most asphalts, most aggregates, et cetera. So there's some really good testing that's out there. Will you touch on the applications for expansive soils and how it performs with geologic hazards such as liquefiable soils and landslides? And Tom, I kind of threw an audible, so thanks for getting this question early. So I do have our liquefaction presentation queued if we want to bring that up, but if you want to talk about expansive clays real quick.
Well, it's not going to solve necessarily be like if you've got expansive clays can still be an issue. It's not there for mitigation of it's not going to stop it from being expansive soil, but we don't tend to have issues with working with those at all. I'm not sure exactly what whether I'm answering your question or not, but it can be used in expansive soils without issues. We realize that it's always going to be a problem. We're not completely always filling in when we're dealing with expansive soils. For instance, we may leave some room. If we're injecting on a grid, we may leave some space for that to expand around it. But if you have something more specific on the question there, that might help me a little bit on trying to explain it.
Yeah.
If you want to pull up liquefaction, you can, but there have been some studies done on that. It's a great alternative for liquefaction mitigation on post construction. With new construction, I realize that there's a lot of alternative methods like wick drains and things like that are common and probably going to be cheaper. But once a building's built, if it needs that liquefaction mitigation, those aren't really a good option anymore. And so, you want to drill a bunch of holes through the floor of a courthouse or a building, whatever, to try and put those drains in it. But our deep injection process that we've used for stabilizing structures and soils over the years is a great way to mitigate liquefaction, especially on existing structures.
Yeah, I'll add a couple points to that if you don't mind.
Yeah.
Typically with expansive clays, the polyurethane is used, especially in deep injection applications in zones like Texas and Arkansas and a variety of different other areas that are prone to expandable soils. It's not going to chemically change the soil. It's not going to stop the expansion from occurring, but at enough saturation, it might prevent some of the water absorption. But it also provides We typically advise and utilize it in certain, whatever the condition is of the soil from a saturation standpoint. If it's extremely dry, it can permeate and fracture, all the various different elements of the expansive clays, especially as it's dried and a little bit brittle. The problem you have in that is if it does expand, it may cause some unneeded lift in regards to your structure that it's supporting. If it's overly saturated, the material is going to spread, but it's going to kind of spread in a bulbous way and push the soil out, and it's not going to permeate. So we kind of advise if it's going to be used in an environment with expansion to utilize it kind of in the in-between stages as far as the saturation and the expansion are concerned. I know that's just coming from some experience that we have, especially folks in those regions that are continuously dealing with that. But again, from a chemical standpoint, it's not going to augment it. I do want to just talk about this, and I hope y'all don't mind this audible. Our company, Eagle Lift, one of our customers, Eagle Lift, who is now a Groundworks entity, they conducted some tests with the University of California, San Diego. I think this was around 2019. They did a large shake table test and just were doing exactly that, which was testing, what was soil improvement that they could make around liquefiable soils. I'll try and speed through this. A little bit about the shake table, laminated steel plates. It vibrates, it moves, it gives a lot of opportunity for extreme vibration to cause liquefaction to occur within those type of soils. There's a little bit more on that. Again, we'd advise you to reach out. The folks at Eagle Lift and Groundworks are excellent at this. Here's the shake table test in a preliminary pre-injection. So centered column, concrete weight, very directed weight place, and it just caused the material, the building or the build structure to just sink immediately. Then they conducted injections around the perimeter and within the soil, the liquefiable soils underneath the structure. Technical data is more, but I'm trying to keep this quick for questions so we can get to the other questions. And this was a post-injection where they tested it. There was almost no settlement of the soil in post-injection. You can even see the water starting to shift upward within the sides of the container. So it was some pretty intense vibration that was occurring. Afterward, they dug out the polymer to find out what the polymer sand composite would look like. And then they could also provide some 3D modeling that occurred around it. But as you can see, like especially in highly compact soils, the polyurethane kind of fractures the soil and creates this sort of lensing / lattice effect, which ends up increasing overall soil, but also increases soil density pretty heavy. Here's a 3D image of what that polymer soil sand composite looks like in post. And then did an additional 3D rendering of that occurred as well. What they found is total composite volume was actually 3.5 times that of the injected liquid polymer. And here's some, hot maps, if you will, of what the pre and post injections look like. But they had an overall bearing increase of over 90%, at 0 to 3 to 0.6 meters. And they had an overall fourfold increase in liquefaction resistance that occurred. So it's an excellent study. This was published in the ASCE journal. Excuse me, it was the ASCE journal. But we can get you more information if you guys would like to see more on that. Tom, you're welcome to take over the screen. I'm going to go to the next question. We've been providing examples of recommendations for different applications for soil engineers who are not familiar to provide to engineers. Tom, I think we're happy to support any requests that they have as far as materials to support any kind of lunch and learns or any kind of direct engineering.
Yeah, absolutely. We're happy to do lunch and learns. Technical data sheets are available on the website, but we can also get you PDF. You can download PDF copies, but I'm happy to send them along as well as STSs as needed. But yeah, I mean, we have a plethora of different presentations other than this one that we're happy to do. We can tailor a lunch and learn towards, your organization, the type of work that you do, and what you're interested in hearing about.
Great. What's the flexibility of contraction and expansion of the applied product?
The it doesn't really get affected by it, so it has very little water absorption. It's pretty dimensionally stable. It's not going to expand and contract with cold like other materials do per se. Um, Now, as far as flexibility, things like that, the tensile strength, compressive strength, um, uh, flexural strength, all those things are on the technical data sheet. And that's going to vary from system to system. The more rigid it is, the less flexible it's going to be. Um, but all that stuff is on the data sheet.
Wonderful. With the hydrophobic foam set up in water deeper than a couple of inches, what's the threshold?
Say that again. I'm sorry.
Well, the hydrophobic foams set up in water deeper than a couple of inches, basically, can it
Yeah.
be injected in water?
Yeah. Yeah, you could have a cavity or a void that's completely full of water. It's still going to make good foam and displace the water and push it out of the way. That's why it's important. That's why we put it in there, because we do have a couple of systems that are not hydrophobic. One of our most popular concrete lifting systems, our 2.8F, been around for years, one of our oldest systems. It's not hydrophobic. It'll be fine. It's fast enough that if there's a little bit of moisture present or water present in the void, no big deal. But I wouldn't want to use it if I had a 2 foot deep void that was completely full of water. It's not going to make good foam in that situation. We have systems that will work for that situation. We have our 3FH, which is just slightly denser at 3 pounds, but the same speed profile as the 2.8F. So works really well in those wet conditions.
Excellent. Are the products closed cell, open cell, or does it depend? If open cell,
Closed
can the permeability be controlled through design?
They're all closed cell, and therefore not permeable. I mean, the number on there for water absorption is very minute. It gets, over, if it's completely saturated, it's going to get just a little bit on the outside, and that's about it. It's not going to take on a lot of water because it is a closed cell structure. So the only way we can work with situations where we need some water to move is to try not to fill the entire area. Um, it, it it's not gonna let the water through. I know there are some situations where you want that. I know, like with cellular concrete, they have versions where water will flow right through it, and that's great. We don't have that. An open cell foam would not work well in these situations. It's just not rigid enough. When you talk open cell foams, our closed cell systems here start in the 2 pound piece, 2 pounds per cubic foot range. Open cell is going to be half-pound foam. I believe there's some 7.75 PCF as well, but it's not going to do well on the ground. It's too spongy to really work for those situations.
Absolutely. And then also please note that we covered about four different materials today. These were really geared towards more of like these adaptability situations, non-traditional uses. We have over 20 formulations that we haven't. I mean, we've covered all in that 20, but we've got about 15 other formulations that we haven't covered that are available for a variety of applications. So please attend our other webinars to learn more about those. What is the best product for bridge approach slab and abutment void fill?
If it's truly void fill, depending on the size of the void, you could potentially, as long as engineers are good with it, use, one of the low exotherm systems. But typically, our most widely approved system for DOT work is going to be our 4RH. It gets you that compressive strength that you're looking for, and if you've got large voids and you need that higher compressive strength, you can still do it with polyurethane. You just need to take your time and do it right. It just has to be done in lifts. It can't just be injected full blast. If you've got a 2 foot void there, you got to put it in lifts, let it cool off a little bit, move to the other side, that type of thing. But that's going to be your most commonly used one for sure.
Excellent. Have the shake table test results been published? If so, where? I'm going to try and find the link for that, and I'll put it into the answer within here. If you don't get it, please feel free to email me. I'm noting who's here, but I'm sure there's a variety of people who are interested in that study. I'll make sure that you get them. Assuming very loose sand, what is the practicable injection depth? I guess what's practical?
Well, it depends on what we're trying to accomplish. If we're talking about permeation grouting, the really any depth if it's loose sand. I mean, we have a soils report that indicates that that the flow counts are low enough. The injection depth doesn't really matter that much. The only time we worry about depth really is a lot of times when you're super deep, it's the soil is going to be rather compact and it's going to be harder to permeate. But if you have a report showing that there's loose soils at -20 feet or even -50 feet, if you can get it there, if you've got the means to get it there, and that's a big part of it, it's really easy to get into this and do injections down to 10 or 12, 15 feet. You start getting a lot deeper than that, and then you need to be able to make sure that you've got a means and method to get the pipe or tubing in the ground to that depth. When we're talking dual component, we do have some constraints there. If you needed to go 100 feet, you'd be hard pressed to get one of our faster, systems through the tubing before it's expanded and locks the tube up. We've successfully done projects, deeper than 50 feet, probably 50 or 60 feet. A lot of times we're not looking a whole lot deeper than that because the structure that we're trying to support doesn't have a zone of influence that goes down much deeper than that per se. But yeah, the timing for those is important. You want to make sure you use the right system that has a long enough run time to get through the tubing and get it to where it needs to go. And then as far as like the single component doesn't react until it gets into the wet soil. It reacts with moisture. And so sometimes you end up having to use a tube machette style thing to keep water out of your tube before you start pumping. But you can pump that to any depth that you can get it to. I hope that answers the question.
Yes. Is there any way to clean stains off concrete slab from cured foam?
Well, we are looking at a material right now that somebody's wanting us to try out. We haven't tried it yet, to be honest with you. Heard good things about it. We will definitely make an announcement if we decide to start carrying it. As usual, we'll give the normal spiel. If you can keep it from happening to begin with, then that's the best practice. But it happens, right? Using water or soapy water to keep the surrounding concrete in the work area wet will definitely help keep those incidents from happening. But if it does happen, it is kind of difficult to get it off. The sooner you can react, the better. If it's happening right in front of you and you have a can of carb cleaner or brake cleaner, spraying it on there while it's reacting will usually help and potentially stop it. But it's once it's happened, getting it off There are some techniques. I mean, you can sandblast it, you can media blast it. There's a couple of different techniques for getting it off, but they're not necessarily inexpensive. So we'll let everybody know if we decide to start carrying this product. It is a chemical product that somebody's come to us with that we're thinking about potentially carrying for our contractors to use if they do have these incidents. But that's that's the gist of it, is try to stop it from happening in the first place.
This is an interesting question. We may have to get, I'm not sure. Can you repeat if there's a reaction with soils with high sulfates?
That would be a good one for our chemists. I've not heard of anything with that being an issue. Yeah, it should not be, but I would have to be, completely sure about that. I would want to probably run that by my R&D folks. So if you'll get Robert your contact information, we can get you a more solid answer on that. I'm not
Yes,
aware of
please. Yeah.
it.
Please send that. It's the first time I've heard a high sulfate question before. So, and I've been hit with a lot. So,
Yeah,
thanks for
yeah,
giving us that one. That'll be a good one to answer, and I'll make sure to follow up with you. I did, and if you're able to see the answered questions in the Q&A, I did provide the ASC library link for the liquefaction study. So, please reference it there. Again, feel free to reach out to us. I've also made sure to include mine and also Tom's emails in the answered section. So happy to answer any questions post this. Check to see if we have any more questions. No, Tom, I think that's it. And we are 1 minute over. So this is probably the most timely webinar we've had. Want to thank everybody for coming on. I want to just make a couple notes that if you are seeking a PDH certificate, when you close out this webinar, you will receive, it should bring you over to a browser window to a form. Within that form, I have it automatically indicating that you do want a PDH, but make sure that it's clicked to yes if you want one. Please fill out the form in its entirety, and from there you should receive an email from me that has the PDH within it. If you run any issues, feel free to reach out. Happy to support you in any way we can. Tom, anything to close out for today?
Just thank you very much for attending today, and keep an eye out for our next webinar. And let us know
Excellent.
if we can help with with any type of presentation for your organization. Be happy to do it.
Wonderful. All right. Thanks, everyone. Have a great day.